Okay, so you just went through that Desmos activity that helped you maybe determine what this plus C is going to do to our graph. So we already know that if we have ax squared, that a is going to stretch or shrink our graph, okay? In terms of it's going to make it wider or it's going to make it narrower, okay? Well, now, if we have this plus c added to the end of our equation, we know that that is going to shift our parabola up that much. Or if we have a minus c after that ax squared, then that is going to shift our parabola down that number. Okay, so let's go ahead and go to the next page, and we're looking at this number 1 on the extra practice. Okay, well, let's talk about some things. First of all, I noticed that there's no number in front of x squared. So this is essentially just a normal parabola. However, we have this plus 5. Well, what is that plus 5 going to do? This is going to shift our parabola up 5. Okay, so what we're going to notice when we make our XY chart, okay, when we plug in 0, remember, I like you to start at 0. This is where our vertex is going to be. Instead of getting 0 as our y coordinate, when we plug in 0 to x squared plus 5, we are going to get 5. Okay. If we were to plug 1 in to x squared plus 5, we're going to get 6. Okay, or we should see some symmetry here. If we plug negative 1 into x squared plus 5, we should get 6. If we plug 2 into x squared plus 5, we're going to get 9. And if we plug negative 2 into x squared plus 5, we're going to get 9. Okay, so I'm going to draw my x and y axis, and I drew my x-axis a little bit lower so I have some more room. Okay, we know that since this is where we are having that symmetry, this is going to be our vertex. Okay, 1, 2, 3, 4, 5. Here's our vertex right here at 0, 5. Okay, and then at 1, 6 and negative 1, 6, we have coordinates. Now, I don't think I'm going to have room for my 2, 9 and my negative 2, 9, and that's okay. It's okay. Okay, there's our parabola. Okay, so it looks the exact same shape as y equals x squared. Okay, if I had x squared, then that would be, down here. And this is just shifted up 5. Okay, now let's talk real quick about some things we can identify from this graph. Okay, we know that our vertex is at 0, 5. Okay. We also can identify that axis of symmetry. I am going to write it like this because I don't have room to write axis of symmetry, is that vertical line x equals 0. Okay. When we talk about domain and range, the domain for a quadratic function is always going to be all real numbers, okay? But the range is going to change. Since this got shifted up 5, I only have y values up here when we're greater than or equal to 5. I have y values from 5 and above. Okay. All right. Let's talk about number 2. How does number 2 look different? Okay. It looks like number 2 is the same shape as x squared. However, this minus 3 is going to shift our parabola down 3. So when I make my XY chart, I'm going to plug 0 in for x first. That's where our vertex is going to be. Now, if I plug 0 into x squared minus 3, then our y value is going to be 3. If I plug 1 into x squared minus 3, then our y value is going to be negative 2. If I plug negative 1 into x squared minus 3, then our y value is going to be negative 2. Let's just go ahead and do a little bit more symmetry here. If we plug 2 into x squared minus 3, it's going to give us 1. We plug negative 2 into x squared minus 3. Negative 2 squared is 4, minus 3 gives us 1. Oops. I forgot my negative on our vertex. Sorry, guys. Okay, so here's what our graph should look like. Make sure you have it graphed with this XY table also. Okay, let's look at number 3. Let's talk about how number 3 is going to look different. Okay, there's 2 things that we need to identify here. Well, actually 3. Okay, first of all, this negative means our graph is going to be reflected. So this is going to be an upside down parabola. We know it's going to go upside down. Okay. Second, this 3 right here, how is that affecting our parabola? Is it making it wider or is it making it skinnier? Okay. Or narrower, if you'd rather use that word. Okay, that 3, since it's bigger than 1, is going to make our parabola a lot skinnier. Now let's talk about that minus 2. That minus 2 is going to shift our parabola down 2. Okay, so in our mind, we already know what this parabola needs to look like. Okay, so let's make our XY table. We'll start with 0 in the middle for our vertex. Okay, and if we plug in 0, I'm going to come up here. If we plug in 0 to negative 3, 0 squared minus 2. Well, negative 3 times 0 is 0. Minus 2. Okay. Now let's go ahead and plug in 1. If I plug in 1, it looks like we would get negative 5. We plug in negative 1, again, negative 5. Now let's plug in 2 and negative 2. If we plug in 2, we would have negative 3 times 4 minus 2. And then same thing with when we plug in negative 2. Okay, we are probably not going to be able to fit those on our graph. So I'm going to make my x and y axis so that my x-axis is kind of towards the top. because when I plot this, my vertex is going to be 0, -2. And then we have 1, 5, and -1, -5. 1, -5, and -1, 5. And then I am not going to be able, oh, hold on. I did not plot those right. There we go. We are not going to be able to fit our other 2 points on there. So those 3 will be fine. Okay. Now let's talk about the range of this graph. We know that the domain is all real numbers, but let's go and talk about the range. Now we're upside down, okay? So we only have y values from here and below. So our range is going to be y is less than or equal to -2 because our y values start at -2 and they're below. All right, I'm going to give you a moment. I want you to graph number 4. So what I want you to do is I want you to press pause, and when you have a graph, then press play. Okay, so when you graph this, okay, let's talk about how this is going to be wide and shifted down 4. Okay, so when we plug in 0, we're going to get -4. Okay, now if you plugged in 1 and -1, it's fine, but we are getting fractions, right? We would get -3.5 for both of those, okay? It may be easier to plug into a -2 because then we would get -2. Okay, and if you wanted, you could also plug in 4 and -4. Because if you plug in 4 or -4, you would get 1/2 times 16, which is 8, minus 4, which is 4. Okay, so notice how that's just a touch wider, okay? If we didn't have that 1/2, then this is what our graph would look like, okay? All right, so now what I want to do, I want to go ahead and go to the next page. I want to look at number 9, all right? I want a parabola that opens down with a vertex at 0, 5. So let's go ahead and plot 1, 2, 3, 4, all the way up here. So here is my vertex of 0, 5, and I know I want this parabola to open down. Well, what would be our equation? We know we need it to go up 5, so let's put that plus 5 at the end. And we know we need it to open down, so we can put a minus out in front. Technically, that could be any number that's negative because it's saying it just wants to open down. It doesn't say anything about being narrow or wide. So technically there'd be a lot of different answers, but this would be the most basic answer. We have a reflection to make it go upside down, and it's shifted up 5. Okay. Now, how about number 10? It says the lowest point on the parabola is 0, 4. Okay, well, what does that mean? Here's 1, 2, 3. Here's 0, 4. That's the lowest point. Well, if my parabola is opening down, that would be my highest point. So if it's our lowest point, then we have a parabola opening up, which means we would have y equals x squared and then we would have to add 4 to get that vertex to be up 4. Okay. Your job now is to do the book assignment that I have posted in Google Classroom. Make sure you check your answers and you're ready with your homework done for tomorrow.